is Miss Roll. In today's video, we are going to go over what subatomic particles are. I abbreviate these with the letters PNE, and you'll see why in just a minute. But the goal of today's video is for you to understand what these particles are, where we can find them, and how we identify how many an element has off of the periodic table. So first of all, we're talking about the inside of an atom. Hopefully you already have a decent idea of what an atom is. But inside that atom, we have things called subatomic particles, which if you think about that word, sub means like inside of, and atomic, the atom. So it literally means inside the atom. And we have three of these subatomic particles: protons, neutrons, and electrons. I'm going to move where my camera is. There you go. So these three particles, protons, neutrons, and electrons, are what make up the atom. That's why I abbreviate PNE, protons, neutrons, and electrons. Those of you who've been in my class before know that I've mentioned that scientists are lazy, so we like to abbreviate everything. So that's why we have the shortened PNE. So the first thing we need to know about these particles is what their charge is. This gets really important when we start talking about ions, which you'll see in a later video. So protons are positively charged, right? Pro, you think of like a positive kind of connotation to that word. So that's a good way to remember it. They're positively charged. Neutrons have a neutral charge or no charge. So again, it sounds kind of like the word neutral, which is like a no charge. So that's a good way to remember it. And finally, we have electrons, which are negatively charged. Now, you could just remember that electrons are the one that doesn't sound like positive or negative, so it's negative. But another way you can think about it is electron sounds like electricity, and if you got electrocuted, that would not be good. It would be pretty negative. So that might be another way to help you remember that electrons are negatively charged. Next, we need to talk about their mass. The reason we talk about the mass is when we get to isotopes. And again, you'll see that in a later video. But basically, we define the mass based on the mass of one of our protons. So both a proton and a neutron each weigh about 1. Because they're based off of what those particles are. They're each 1. And then the electron has essentially no mass. Again, this is just in our particular unit system, and this is the way that we talk about them at this level. If you get way further on into chemistry or physics, you'll talk more specifically about what that mass looks like. But for our purposes, proton and neutron each have a mass of 1, and the electron does not have a mass. Finally, we got to talk about where these subatomic particles live. Both protons and neutrons live in the nucleus, and then the electrons live on the energy levels. We'll talk more about what those parts are on the next slide. There we go. So what is our structure of the atom? The nucleus. So this is the center part of your atom. This is what's in the middle of the atom. In the GIF on the last slide, you saw kind of the red and blue that was in the center. That's our nucleus. The nucleus contains all the mass of an atom. We mentioned how only protons and neutrons have mass. And since both of those things live in the nucleus, that's the part that makes up the mass of an atom. Protons and neutrons, again, are located in the nucleus. Those are the two particles that live in that center part. The electron cloud, or energy levels, you might also hear referred to as energy shells. This spot is where those electrons live, and it's outside of the nucleus. It's kind of that orange fuzzy thing on the picture on the screen, that area around the nucleus. We'll talk more about why we say there are levels and where electrons live within that area, but that kind of zone is where electrons could be in our atom. So now we get to talk about how to actually read our periodic table. So there's a couple of different pieces of information on the periodic table squares, each individual square, that I need you to know about. So first of all is that atomic number. That is the number of protons. That lovely number right up at the top of our element square is our atomic number. And it tells us that number of protons. Each atom, so each element, has its own atomic number, a different number for each of them. So it's kind of like a fingerprint. That number is what defines which element it is. So any atom that happens to have 6 protons is a carbon atom. Any atom that has 7 protons is a nitrogen atom. Okay, it defines what that element is. The next number that we have on our periodic table is the atomic mass. This is the average mass of all variations of an atom. So I've already mentioned the terms ions and isotopes. Those are some variations on our atom. So they're still the same element, but they're variations. We will learn what those are in a later video. But some of those variations affects the mass of that atom. And so we take the average, and that gives us this atomic mass that is on the bottom of our periodic table. So it's that 12.011 for this example of carbon. And then the next thing, and this is kind of the more useful bit, is the mass number. So this happens to be the sum of protons and neutrons, protons plus neutrons. And then also for our purposes in this class, you can find the mass number by rounding the atomic mass. This doesn't work for all elements, but in our class, the elements that you will see in our class, you can round the atomic mass. So for example, in this carbon example here, we've got 12.011, which would just round to 12. Okay? Because again, it's 0 after the decimal point, so it would simply round to 12 and stay at 12. Okay? Pretty straightforward bits of information off of our periodic table square. You'll get very familiar with these, but that's our quick definition of what those numbers are. So now let's talk a little bit more about how exactly to find that PNE, protons, neutrons, and electrons from our periodic table square. So these 3 things are probably some of the most important that you'll need to remember from this video. So first of all, both protons and electrons, if you're looking there, both of these are the atomic number, right? For protons and electrons. It's just that atomic number. There are, again, some variations where that number of electrons might not be the same. But for right now, we know the number of protons and the number of electrons simply based on that atomic number. Under electrons there, it says in a neutral atom, so one that has an overall 0 charge, meaning the same number of protons and electrons. There are cases where they're not the same, and again, we'll talk about that in a later video. Neutrons now, we need to figure out by doing just a little bit of math. So I had mentioned previously that our mass number is protons plus neutrons. So if we can find the mass number by rounding that atomic mass, and we know the number of protons because it's our atomic number, rearrange that a little bit and we can figure out that neutrons are the mass number minus the atomic number. So if we take a look over here at our example of Na, and that element actually happens to be sodium. It's based on its Greek or Latin name. Our atomic mass down here is 22.99. A quick little rhyme that'll help you remember when you round. 5 and above, give it a shove. So if that number after our decimal point here is 5 or higher, we want to round up, which means this number is going to go to be a mass number of 23. So to figure out our neutrons, we're going to end up doing 23 minus 11. And 23 minus 11 gives us 12 neutrons. So our protons and electrons would have been 11, and our neutrons would have been 12. The best way to get more familiar with this is to do a little bit of practice. So that's what we're going to do here on these next slides. There we go. So first of all, here is magnesium. I gave you the element square there. And we're going to go through this one together. So first of all, we need to figure out what the atomic number is. Well, that's our number here up at the top. And that's just going to be 12. The writing will disappear after a couple of seconds, so feel free to pause and go back if you need to. But the atomic number of 12 also tells us our number of protons and electrons. So we have 12 protons and 12 electrons. Now we have to do that little bit of math and figure out the number of neutrons by first taking this atomic mass and rounding it. Our number after the decimal is a 3, which is less than 5, so we're going to keep it at 24. So our mass number is 24. And now we just have to do mass number minus atomic number. So 24 minus 12, and that's going to give us 12 neutrons. Okay, pretty simple, pretty straightforward. But again, practicing this is one of the easiest ways to figure this out. We're going to go on to our next example. If I can get it to switch. And here we have calcium. What I would like you to do is take a moment, pause the video, and see if you can find the atomic number of protons, neutrons, and electrons all on your own. All right, hopefully you had a chance to pause the video there and figure out how many you think there are. So we'll go through it together. But I'm going to go a little faster. So our atomic number at the top, also tells us protons and electrons. So we have 20 for our atomic number, for our number of protons, and for our number of electrons. Now we have to take this atomic mass, round it, which gives us a mass number just of 40. Because after our decimal point there is a 0, so that means we're going to stay down at 40. And then we'll do our 40 for our mass number minus our atomic number of 20. And that gives us 20 neutrons. So it happened that all 4 of your numbers here were 20. If you got stuck, if you didn't figure that out, see if you can go back and see where you went wrong. Otherwise, make sure that you email or use those Google Hangout hours to ask a question. We're going to go on to our next example here. And this one is a little bit tricky. I gave you a different question. So in this case, I tell you that iodine happens to have 74 neutrons. So I'm asking you some of the same questions. What's our atomic number? How many protons and how many electrons? So let's start with that before we get to the part that's a little bit different. So again, for the atomic number, it's just that lovely number right up top. I have 53 for my atomic number, meaning I have 53 protons, and I have 53 electrons. Okay, that's the easy part. Now, in this case, I'm telling you how many neutrons, and I'm asking for that mass number. You'll notice that I covered it up on our periodic table square. So if you remember that mass number is protons plus neutrons, and you know the number of protons, and you know the number of neutrons, you should be able to figure out that mass number. So in this case, I need my protons, which was 53, and I'm going to add, let's wait for that to erase because I miswrote it there, 53 plus 74, and that's going to give me a mass number of 127. 127 happens to be our mass number. Okay. Hopefully that one makes sense. Look back at the 2 slides where we talked about reading the periodic table square, because you remember that neutrons are the mass number minus atomic number, and our mass number is protons plus neutrons. Okay, so hopefully that makes sense. Again, make sure that you ask a question if that seems a little bit confusing. We're going to go on to our next example here. Same questions as this last one. So we're looking at francium. And I tell you that francium has 136 neutrons. So still you're looking for that atomic number, protons, and electrons. And now you got to find the mass number. So again, take a second, pause the video, and try to figure those out on your own. All right. Hopefully you had a chance to do that. We are going to look for that atomic number. Again, it's our number right up at the top, 87. And that tells us also our protons and our electrons Okay, so again, 3 of our numbers are exactly the same. And now we got to do that little bit of math. So to find our mass number, we're doing protons plus neutrons. So that was 87 plus 136. And that gives us a total of 223 for our mass number. So again, looking through these examples and kind of following along and understanding those is the best way to practice identifying PNE off of your periodic table squares. Your next assignment will be a practice on doing that. But again, please, if you have any questions, if things are a bit confusing, make sure that you are contacting us and asking those questions. Other than that, that's it for this video. I hope you have a wonderful day.